Okay, so the true population mean of HAV in patients under the age of 21 who came for surgery. Boy, this sounds really fun, doesn't it? Sorry for these people. Okay, so this is our P, okay? So if we were talking about panic, you know, like how to do a confidence interval, like free response, this would be our P. And P at home means parameter. So this is what you have to do if it's a free response question. Now this is our A. Assumptions, I call them conditions. Okay, so assumptions. Okay, so does it say in the problem it's an SRS? What does it say? We are willing to consider, so it's stated in the problem. And now, how is it stated in the problem? Okay, that's how it's stated in the problem. Now our next condition is normality. Okay, and how many patients do we have?
38.
So CLT states what's another way that you could say this? What's another way you could have said that? CLT states that if our sample size is large enough, greater than or equal to 30, we have 38, our distribution is approximately normal, right? So either way. Amy, did you have something?
No, that's okay.
Are you sure?
Yeah.
Okay. And then the last one, oh, but we're not done. Why are we not done? Why do we have to have a box plot? This is important. Why do we have to have a box plot?
Because there's data.
There's data.
People say so.
Yep. It's you have to draw. It wouldn't matter anyways. You have to draw it because they gave you data. They gave you data, and you have to make sure if there's outliers or anything like that. So to remember to do that, my stuff is in list 1, so I'm going to do a second y equals. My list is on, and I'm going to do a zoom 9. And I do have one outlier. So I need to say that, right? Even though I have one outlier, CLT applies, and the rest of the data is pretty what? It's approximately what? Symmetrical. That's a beautiful box plot. It's not great, but it's beautiful. But we do need to say there is an outlier. We have to talk about that. So you're going to draw your box plot, do a one variable stat, and draw it. Okay. If you forget how to do your variables, you're going to go to calc, one variable stat. My stuff is in list 1, and I'm going to have my 5-number summary right here. So you guys, that max, that 50 is actually your outlier. Okay, so we're going to draw a box plot. And You could probably count, you know what? Let me pause. What's our minimum? Okay. What is our quartile 1? Our median? Quartile 3. And our largest is now, CLT states it, and now you need to talk about your box plot. CLT states that we have it's normality, even though we have an outlier. It's great because our sample size is large enough. The only problem that we have is this outlier, and the rest of the box plot is symmetrical. It's approximately symmetrical. Please do not say the distribution is symmetrical. It's approximately symmetrical. Please never say symmetrical, because nothing is ever exactly symmetrical. Okay. Oh, there we go. Now, what's the last thing we have to prove for our assumptions? Independence. And what is our independence for today? Our population of what?
Sample size.
But what is our population of? Population of patient under the age of 21. Population of
Who came to correct HIV?
Yes, but our population is the people under the age of 21.
Just everyone?
Uh-huh.
Not people with HIV?
You can put that, but it's just the population of people under the age of 21. And it has to be greater than or equal to 10 times 38, which is... And now, this is a good point that you can make. You can say, clearly the population of people under the age of 21 are 380. However, if we're just talking about people that have HIV, we're going to assume that the population of people that have this is greater than 380. Okay? So you can say that. Okay, so that's our assumptions. I'm going to tell you that probably the assumptions take the longest part. And of course, it is a big chunk of the problem. You guys, right here, if you write X bar instead of mu, you lose a point. Just putting the wrong symbol right there. Even if you write this whole thing out correctly, you put the wrong symbol there, it's 1 point. You forget one of these conditions, it's a point. You forget to name your test, it's a point. And you only have 4 points to work with. So let's just think about that. You use the wrong symbol, that's a point. You leave out one of your conditions, that's a point. You forget to name the test, that's a point. Do you guys understand when I'm talking about points? You get 4 points. Please make sure that you go through, and you have plenty of time to go through and make sure you have everything done. Okay, so now we're going to name the test. That's our N. We're going to name, I don't want to say name the test, but name the confidence, so we're going to name it. That's what N means. So is it a 1 proportion Z interval, a 1 proportion T interval, or a 1 proportion Z interval? I said one sample. This is a one sample. Okay, here's the thing. Did they give us sigma? So it's a one sample T interval. You just named the test. Now, with naming the test, let's write the formula that goes with it. The formula would be x bar plus or minus t star times s of x over the square root of n. Our sample size is 38. So what would our t star fall under? So let's write this. So we know our x bar because they're giving it to us. We know our s of x because they'll give it to us. They're going to give us our n, and then what is our degrees of freedom? 37. N is 38. They'll give us our x bar and s of x when it comes up. So you guys, listen, you don't have to fill everything in just yet, okay? So let's look up our t star because your t star, they don't ever give you your t star in your calculator. So go back to your book and find the t star, and we want to be 95% confident. So we're going to go to 95 and 37, but they don't give us 37, do they? So we're going to where are we? We're going to go down 1. We're going to use 30, so we're going to use 2.042. We're just going to use the 30. So we're going to go on the conservative side. That's what they say. When you use the 1, like we should have gone to 37. We don't want to go bigger. We always want to go smaller. Okay, so you always want to go to the 30. You want to always go 30. Don't go to 40. So we're going to be conservative. Now, they're going to expect you to use your calculator, which we already did, right? So let's make sure. Stat over to test. Down to a z interval. I use data, and then I'm going to calculate. My data is in list 1. Frequency is always 1. Your confidence interval is whatever they give you. You hit calculate. My x bar is 25.4211. My s of x is 7.4748. And my interval is 22.964 to 27. Oh, Lord have mercy. Let's try this again. 22.964 to 27.878. Okay, so what does that mean? This problem right here will give you 3 points. Everything we've done so far should give you 3 points. The last part is the conclusion. The conclusion states, I'm not going to be able to fit it on here, but we are 95% confident, or I am percent confident that the true, and now you're going to take that sentence that we wrote up at the top, you know where we define mu? You know that where we define mu, we're going to use that sentence. That the true population mean of HIV in patients under, oh my gosh, I have the hiccups. What is it? Under
21.
the age of 21 who came for surgery is between 22.964 and 27.878. And that right there is a free response problem. They give you, for a free response problem,